What is the probability that a suspected driver is given exactly one test? Well, that would be 0.56 because they were given a breath test, but not a blood test. Or it could have been 0.15 where they were just given a blood test and no breath test. So we've excluded the 0.25 in there. And that adds up to 0.71. 71% of the people pulled over were given only one test. And then what's the probability that we were given no test? We've already found is anything that's not inside the bubble situation at all, and that's 0.04. 4% of all of the people pulled over were given no test. All right. Are the events giving the driver a breath test and giving a driver a blood test independent? We know already that they're not, right? We already know that they are not independent, but we can always find that out by calculating it, and we can prove it by calculating it. So if we were wanting to prove that something was independent, we would either need to prove that the intersection, the probability of the intersection is just equal to the probability of A times the probability of B, or we would need to do that the probability of A given B is just the probability of A. This one's just a little bit easier to prove. We were already given the probability of both of them, right? We were given that the probability of both of them was 25%, 0.25, right? So then we just need to talk about the probability of A, which is 0.81, and the probability of B, which is 0.4, and we just need to multiply them together. Multiplying those two numbers together, what do we get? The multiplication of the probability of A and the probability of B end up being 0.324. 0.324 is not equal to 0.25. Therefore, they are not independent. So remember that this up here is only true if they are independent. So this is just how you practice proving it mathematically. If you know that the probability of them happening together is equal to 0.25, then you take the probability of each of them and multiply them, and if it's not equal to 0.25, then there's some sort of overlap that's happening there. So that's a good way to double check if you're like, well, in this Venn diagram, do these circles overlap? Do they cross over each other? You can multiply these out and see whether or not they actually do. Okay. The last problem that we have written down is example 9. It's just a little nice way to bring in a little bit of what we know about other units. So remember that we've gotten pretty far into our material that we need to have ready for our IB exams, and that now we're going to try and start implementing all the things that we do know, and we need to start piecing it together. So this diagram shows a target for a dart game. The radius of the board is 40 and divided into 3 regions. If you score 2 points, you get the center, 1 point for the middle, and 0 points for the outer region. What is the probability of scoring one in one attempt? So the probability of scoring 1 has to be within this region. And so this idea of the probability of it happening is like the probability of that certain event over the total amount of options that we have available to us. In this case, the probability of an event is dealing with the area, right? The place that you're going to, the place that you're trying to throw that dart to, where you want it to hit is a certain area of this situation. So this area for 1 is this white region. In order to find the area of this white region, we need to find the area of this whole big circle and then subtract out the area of the smaller circle, right? It's a composite figure, so in order to find out the area of that donut, we need to take out the area of the smaller circle in between. And it tells us what the radii of these guys are. So if I want to find the area of if I want to find the probability of scoring 1 point, it's the probability of I'm going to call 1 being the area of 1. The probability of 1 divided by the area of the circle, right? So the whole circle represents the total versus the probability of 1 is that donut area. Well, the area of the whole circle we can say is pi r squared. The radius here is 40. So the whole circle is represented like this. Versus the probability of 1 has to be the probability of this whole circle, which has a radius of 2 plus a radius of 10 plus a radius of 10. So both of these radii add up together to give us a radii of 20. So it's going to be pi times 20 squared, which is this whole circle. And then we just need to subtract out that smaller circle. So it's going to be minus pi, and then the smaller circle has a radius of 10. So what we did is we took the area of the region that we want to hit and divided it by the total area of what we had available to us. That's assuming that we hit the board. We are making that assumption. So now we just need to combine like terms. 20 squared is 400, so I'm going to write that as 400 pi. 10 squared is 100, so minus 100 pi. 40 squared is 1600. I'll write that as 1600 pi. 400 minus 100, remember we can treat pi like a variable if we want to. So that becomes 300 pi divided by 1600 pi, if you can read that. Sorry. That simplifies down to the pi's cancel out, the hundreds cancel out, and all we're left with is 3 over 16. So the probability is 3 over 16 of getting 1 point by throwing the dart. What is the probability of scoring a 2 in one attempt? I want you to try this guy on your own. The probability of scoring a 2 in one attempt is the probability or the area of the circle 2 divided by the area of the whole circle. We've already found the area of the whole circle. Remember, it's that pi times 40 squared. In other words, 1600 pi. The area of this smaller circle, the radius has a measure of 10, and so squaring that is 100, so it makes it 100 pi, right? I just did pi r squared, the radius was 10, squaring it is 100 times pi. The pi's cancel out, the hundreds cancel out, and all we're left with is 1 over 16. Okay, we're going to do one more problem in which we practice making a Venn diagram. So let me grab that for you real quick.